Hi everyone. Today we are going to discuss how to find perpendicular distance from given point P of Z naught to the line in complex form A conjugate Z plus A Z conjugate plus R equal to 0. We know that in real system perpendicular distance from a point P x naught y naught with respect to a straight line Ax plus By plus C equal to 0 is modulus of Ax naught plus By naught plus C divided by root over A square plus B square. That is in real system. Now in complex form, let us find the formula to find perpendicular distance from given point to complex form of line. We know that suppose the equation of straight line is of the form Px plus Qy plus R equal to 0, then it can be written as P of x is clearly real part of Z and y is imaginary part of Z, remaining plus R, it is equal to 0. Real part of Z written as Z plus Z conjugate divided by 2. So that in the next step P of Z plus Z conjugate divided by 2 I am writing. Next Q of imaginary part of Z written as Z minus Z conjugate whole divided by 2 times of iota plus R equal to 0. If you take P common, if you take Z common, what happens inside P by 2 and here plus Q divided by 2 times of I. Next, if you take Z conjugate common, then we get P divided by 2. Next minus, this is Q by 2I with a negative sign. Q divided by 2 times of iota, remaining plus R, it is equal to 0. Now, I can write Z into P by 2 plus multiply with I, divide with I. Next plus Z conjugate P by 2. Negative unity written as square of iota, remaining Q divided by 2 times of iota plus R equal to 0. Now, if you write here square of iota value minus 1, then it become Z into P divided by 2 minus I Q divided by 2. Next plus Z conjugate multiplied by P divided by 2 minus Q I divided by 2 plus R equal to 0. So that here it is plus sign. If it is complex number A, then it can be written as A conjugate. So finally, this is the equation of straight line in complex form. We know that perpendicular distance formula in real system, it is perpendicular distance written as from given point. Suppose the point P x naught y naught. Then you can write here P of x naught plus Q of y naught plus R divided by root over P square plus Q square. You know this. Now let us move to complex form. See, if the equation of line with reference to real system Px plus Qy plus R equal to 0, in complex form, the same equation rewritten as z a conjugate plus z conjugate a plus r equal to 0. See the numerator part in the perpendicular distance, x comma y replaced by x naught y naught there. That is, in the equation of line px plus qy plus r in the numerator, replaced x comma y with x naught y naught. Here in complex system, the point x comma y is clearly zx plus iy. So in place of z, now you have to write z naught, so that perpendicular distance become modulus of z naught a conjugate plus z naught conjugate a plus r. Now denominator part. See here, complex number a in this case, p divided by 2 plus I q divided by 2. This is the complex number a. I can write 2 times of a equal to p plus iq, and from this 2 times of a written as p plus iq. Root over p square plus q square value, that is length of complex number p plus iq. So that length of p plus iq, you can write length of 2a. So that denominator part become 2 times of length of a. This is the formula for perpendicular distance from given point p of z naught to complex form of line a conjugate z plus a z conjugate plus r equal to 0. This is the formula. Let us see an example problem how to find the distance in complex form. Suppose the question is, find the perpendicular distance from z naught 2 plus 3i to the line 1 minus 2iz plus 1 plus 2iz conjugate plus 3 equal to 0. Yes, you know that perpendicular distance in complex system written as general formula I am going to write a conjugate z naught plus a z naught conjugate plus r divided by 2 times of length of a. Here in place of z, we need to substitute z naught value, that is 2 plus 3i. Here a conjugate, what you have, 1 minus 2i. Now in place of z, replace z naught, that is 2 plus 3i. Next plus 1 plus 2i multiplied by conjugate of z naught, that is 2 minus 3i plus 3 whole divided by 2 times of length of complex number a. Complex number a here, by comparing with general complex form, a into z conjugate, a conjugate into z plus r equal to 0 is complex form of line. So that what is a? 1 plus 2i. So length of complex number 1 plus 2i it is. Just to simplify this, you will get perpendicular distance. 1 into 2, 2, 1 into 3i, 3i, next these two minus 4i, next minus 6 iota whole square, that is plus 6, next plus 1 into 2, 2, 1 into 3i minus 3i, 2i into 2, 4i, 2i into minus 3i, that is plus 6, remaining plus 3, put modulus sign, whole divided by 2 times of length of complex number 1 plus 2i, that is root over 1 plus 4. Yes, here plus 4i, minus 4i, minus 3i, plus 3i gets cancelled. 2 plus 6, 8, plus 2, 10, plus 6 plus 3, 19. So that what we get, 19 divided by 2 root 5. This is perpendicular distance from given point Z0 2 plus 3i to complex form of line.